for tuning in this evening. Obviously, a massive thank you to Vadym. So, like I say, a bit of background on the event. For those of you that don't know about me or my business, my name is Barry Cranford. I'm the founder of the LJC and also run a company called RecWorks, which is a tech recruitment company. So at RecWorks, we're all about trying to find ways that recruitment can be a force for good in the tech industry beyond just getting people jobs. And what that means is we're not just about trying to find you your next job, but we really want to help you or help everyone try and find a career that they love, or trying to find a passion within their career and then help them go all in within that. So to give you a bit of a taste, we've run user groups now, built communities of over 10,000 people. We've run over 800 learning focused events, and we've made over 3,000 mentor introductions, so one-to-one mentor introductions. And it's all done for free. So how it basically works is we are paid by companies to find talent, usually developers, and then we take a chunk of that revenue and drive that back into the community initiatives. So this year we've started doing things a bit differently, or something a bit new, a bit different, in that we're trying to create these like learning groups, so that we call them ladder groups. So the idea is to help people go from one place to another on a similar learning path. So one of those groups is the Aspiring Speakers group. So just speaking to Vadym there about how he got started. We've put 50 new people into the LJC this year. So if anyone's interested in getting involved in speaking and following that advice, then please do get in touch. We also run things around aspiring CTOs, aspiring principal engineers, and all sorts of that kind of thing. So if you're interested, then look me up on LinkedIn or Twitter at BC RecWorks, or email, or just get in touch and I can tell you more about it. Anyway, on to this evening. Tonight's presentation is on adapting Java for the serverless world. So we're joined with Vadym Kazulkin, who is the head of technology strategy at ip.labs. He's been involved with the Java ecosystem for over 20 years now, although only speaking for 4. His current focus and interests include the design and implementation of highly scalable and available solutions, serverless and AWS cloud. And he's also the co-organizer of the Java user group Bonn and Serverless Bonn Meetup, and a frequent speaker on various meetups and conferences. So Vadym, when you're ready.
So, yes, I'm ready. So what's the funniest thing is I see a lot of Russian first names in the room now. I see several Alexeys, Timothy, just very, very interesting, Mikhail. So that this are probably Russian speaking audience today, which I'm really happy about because I'm the Ukrainian native. So I will share my screen so we can start the presentation. So now you can probably see currently full screen. I will change to my presenter mode. So yes, thank you, Barry, for the invite. We'll give the talk adopting Java for the serverless world. We'll take the perspective of AWS developer, but there will be many aspects which are really just generic for all other cloud providers or serverless providers. You've already introduced me, so just it's really a lot of joy for me combining my 2 passions. I'm Java developer since probably 23 years, so just started in the Ukraine, and then I moved in the beginning of the century to Germany, where I currently live and work, and just become addicted to AWS cloud. And since 2.5 or nearly 3 years also with serverless, I became an AWS community builder 1 month ago. So just interesting times ahead. So just I work for the company called ip.labs. We are the 100% subsidiary of the FUJIFLM Europe, and we are based in Bonn. This is the city near Cologne and Düsseldorf, which are probably more famous or known. And we deliver software for designing and purchasing of the photo products like calendars, photo books, prints, posters. So everywhere where you can print your memories, your emotions, like the photo book of the year and so on. We are just completely or nearly complete in LWS and just doing a lot of things serverless. And I started there as a Java developer, and we had a lot of Java developers, and then just currently struggling just because Java has some challenges in this space. So just we'll be talking about. There is a lot of private interest from me in this area. So just we're not using everything in production, what I will be talking about, but just we want to be just in line and see what we are heading, so we can just use Java with serverless and so on. So I will be happy to answer your questions in the end of the talk, so I can concentrate on my slides. So I think we may start, and we'll probably, yeah, that's not the basic talk about AWS cloud or serverless. So just I will assume that you have some general knowledge what we are talking about, but of course then we can clarify some points. So just we are Java user group, so probably it's not worth mentioning that Java is very popular programming language, depending on the statistic and how they are gathered, just like Stack Overflow or Job Search, something like this. The Java will be probably in the top 3 and with a huge adoption. So something between 15 and 20% is probably the right adoption. So if we look at adoption of AWS cloud and serverless, just there are a lot of dimensions how you can measure this: infrastructure as a code, platform, infrastructure as a service, platform as a service, and so on. But probably everybody agrees that Amazon Web Services will be way ahead other cloud providers in the most categories. And the same can be told also for their serverless adoption, AWS Lambda. So just the recent statistics, and I will also just share my slides where you see all the links below where I gathered all this information. So you see the serverless solution from AWS just will be used in 87% of the use cases, and other solutions from Azure, from Google, just even things running on Kubernetes, they are way behind. So what we see that AWS Cloud is well adopted, serverless solution from AWS Cloud is well adopted. Generally speaking, there is a lot of attention and noise around serverless. Each survey indicates that there is a huge growth going on. So many people paying attention, and just it's not about proof of concept. So the people use this also in production, like we do at LWS. But just then we will take a look at Java adoption in the serverless space on AWS. We'll see the following. The situation is currently very comfortable, just because Java 8 is supported since the end of 2016, I would say, and even with the extended long-term support, which is called Amazon Correta. This is the Amazon solution for Adopt JDK, Open JDK. So just the long-term support for free. And AWS also supports Java 11 since the end of the last year. So just I think I don't have enough knowledge with other cloud providers, but I think either Google or Azure, they supported Java 8 since 1 year. So just it's really comfortable situation for AWS developer. But what AWS also says, they will only support long-term versions. So the next version will be Java 17 in 1 year, and they will probably support this several months later. But generally, very comfortable situation. And just, we know Java is a very fast and mature programming language. We love it. So just the same is true for me. But if we look at the adoption of Java and the serverless, just the recent service, then the situation is just quite opposite. And what you see, this is the not normalized result, because if you sum up, you will be more than 100%. But just you see Java adoption is 19% and way below Node.js and Python. And that confirms my observation that Node.js and Python are the serverless, the programming languages in the serverless space in all cloud solutions. So another survey, just they published two values, but probably per language. Probably the first one is more relevant, percentages of all functions monitored, and then you see Java is only around 6%. So this is kind of my observation that Java adoption, the serverless space is something between 5 and 10%. So just not that nearly 20% that we see overall. So just what are the problems? So just as Java developers, we would like to use serverless. We are very productive. We've invested in a lot in the learnings and all these frameworks, but just the situation is it's not very well adopted. So before we will be talking about what are the problems, just a bit of basics which are required to understand the things and also challenges and how to solve them. Just how to create Lambda functions. Function is a services Java programming language. So you can simply select your programming language. It's Java 8, but it's also Java 11 is also available. And you also select the maximal accessible memory, starting with 128 kilobyte till 3 gigabytes. And then you can configure timeout, just not to waste too much time. The maximal value is currently 15 minutes, but probably the short-lived function shouldn't run so much. So how you write the code, you have two choices. The first one is using the AWS SDK. So you implement the request handler interface with input and output, and just implement the only one method, handle request, with your business logic. Just business logic doesn't matter in this case. You have also another choice. Instead of using AWS SDK, you can also implement the function interface from Java 8 and then just implement the method apply. What's the difference? Just with relying on the AWS SDK, you will have this context object passed. There is no magic there, but probably if you would like to have logger out of the box, then you can get this from this context object get logger. Otherwise, you can retrieve some valuable information. So running time and remaining time in millis. So just you can log how much time do you have until the timeout occurs, which you have configured, and so on. So generally, some useful information, but it's not necessary to rely on this. So it's up to you what method to prefer. And there is also price model, which is important to understand. And there are two tiers. The first one is request tier. So how many Lambda invocation do you have? This doesn't depend on the programming language, so it depends on your design. And then the duration, function duration. And this is, of course, kind of just depends on your programming language. And you pay 20 cents per million requests, and then you pay this amount per gigabyte second use. So just if you assign 1 gigabyte of your memory for the function which runs 1 second, then you will pay this amount of money. So just one example, you have 1 million requests, you assign half of gigabyte the memory of your Lambda, and we will say that each invocation takes the same 118 milliseconds. In AWS, you will be built. The duration will be rounded to the next 100 milliseconds. So you will be build for 200 milliseconds, and then you pay this for request here for million requests, and then you will pay this amount of just for gigabyte seconds. So just the sum of this, that's the cost of your function. So now just we've understood the basic how to create the function, how the function is priced. Just we will look at the challenges why the Java adoption is some kind of difficult, but there is also the light in the end. So the main challenge is so-called cold start, and probably many people know, but just in case you deploy your function, for example, for the first time. So you have created your function, and then you would like to call it. Just what happens, you have to upload your code. This is in S3 in LWS. Just if your code will be executed for the first time, it should be downloaded. This is the first step. Then the execution environment should be started. Some kind of container environment. It's not Docker, it's Firecracker, but it doesn't matter. And what happens there, we will dive deeply. So this starting of execution environment, it starts Firecracker VM, and then Java execution environment will be started. So just GVM will be started, and then also Java runtime loads and initializes this handler class, just this class with one method, which we saw. And the first thing which will occur, this static initializer block will be executed from our class. And what's very interesting is just that we will have access to the full CPU for the static initializer block for 10 seconds. And why this is important? It's because if we assign the memory to our function, the CPU cycles will be assigned proportionally. So you will get only access to the full CPU if you will assign approximately 2 gigabytes of memory. So if you assign only 128 megabytes of memory for the function execution, you will only receive the fraction of the CPU. But for the static initializer block, you will receive the completely full CPU access for 10 seconds. So you have the possibility to speed up things, and it will be important. And the last step is, of course, just this handler function. So the handler method will be executed. So these 3 steps are called cold start. So they will be executed if there is the first execution or there is no warm container. And if there is warm container, only your handler function will be called. And the container is only there to execute the one function in parallel. So the container won't be reused from parallel execution. So one execution, and then if the execution is over, then the container will be released as a warm container. It can be reused. So generally, it's possible that you made a request to your Lambda and just there is no warm container. So you probably have 8 warm containers, but 10 executions of your function in parallel. So 2 new containers should be started to handle this for not to waste. So the situation is there is no warm environment. So then the available resources should be found, and then this going down. So download your code, start execution environment, execute your initializer block, and then invoke your function, and then you are complete. So in case you have a lot of warm containers which are not busy, then these steps will be skipped and only your function will be executed. The situation is that this container will be released automatically after some amount of time. LWS doesn't provide the values, but people tested this and they say so something like just after 1 hour, the container will be destroyed either way because of security reasons and so on. So you will experience this cold starts from time to time. And just what's the problem with this? A lot of resources, just people measure this depending on your programming language, and just you see for Java, the values are something just half a second or 1.7 0.7 seconds. And then you see JavaScript and Python, they have less, just the cold start duration is really lower. And that's probably one of the reasons. And the second one is that this value for the Java below 1 second is only for very simple hello world application without any dependency. So just as best case of the cold start. And it will go up significantly for more complex scenarios. So depending on what you are doing in your static initializer block, so you're probably relying on other AWS services or other third-party libraries, so they have to be initialized, and it also takes time. And also depends on your artifact size. So there is a recent book from Mike Roberts, just Lambda for Java developers, and he tested just the size of the package. So small package with 1 kilobyte of your application, then large with 48 megabytes, in large ABBA jar, where he simply unpacks each jar and then repacks everything with only 1 jar. He calls this ABBA jar. And just probably a lot of colorful thing, but what you see, these values of the cold start, which are quite low, there are for the small package size. So just if you increase your package size, if you pack a lot of dependencies to other third parties, then your cold start will grow. So just you see the values below 1 second in case you have 48 megabytes. So just you can do test on your own and then see just, yeah, that it becomes more. And just it can be even more than 10 and 20 seconds if we don't apply best practices we will be talking about. So just the situation may become very, very bad with Java if you ignore best practices. But if you take care of this, then the situation is becoming really better. So just coming back to this survey from the last year, and what they also say that they expect the adoption trends for Java to increase in this year. And what they also say, there are two features from LWS, provision concurrency and VPC improvements, which really make the situation better for Java developers. So we will be talking briefly about both of them. So provision concurrency for Lambda functions. So this is the situation. It's 9 o'clock in the evening, and you have your serverless Java application, and then just you are sending newsletter to the millions of people, and just the people click the newsletter link on the nearly same time, and just then you probably experience a lot of cold starts, and just you saw that this cold starts may be significant. So one of the solutions for this is to pre-warm containers. And this is the feature provision concurrency is all about. If you know such situation in advance, and then you may say, okay, at 9 o'clock, I need 1,000 warm containers, then you can pre-warm them 10 minutes before and then release them 1 hour later. So this is the situation that you can decrease cold starts, and very good solution for languages such as Java and C#. Of course, you have to manage this pre-warming and then releasing, just this, and of course, you will be paying for your containers for staying warm, even if you don't need this. So this is some kind of overpaying versus cold start. So just think, if you have these huge spikes and that you don't want your users to wait for seconds, which will probably make user experience worse. So just you have this opportunity, but of course, you have to pay this. Another thing, this virtual private cloud may be not very understandable for the people which are not very familiar with LWS, but generally speaking, in case your Lambda talks to some specific services like managed Elastic Cache, like managed Elasticsearch, or managed relational database, with one exception, these three services are required to be put behind the virtual private cloud, so kind of firewall. In this case, you also have to put your Lambda behind the firewall. And 1 year ago, the situation was that this cold starts in the VPC had significant impact. So just it could take up to 10 seconds additionally. So in the worst case, you had the cold start behind the VPC and then the cold start of Lambda itself. And then just it was really, really worse per design. But what happened last year that AWS improved the architecture, how they scale all these network interfaces. Just currently they're scaling them if you deploy your Lambda function and not then you call this. So this reduced the cold start of Lambda behind the VPC to below 1 second from 10 seconds. So it's not a huge issue anymore. And people really using relational databases with Lambda. So just there were no way around to reduce this cold starts 1 year ago, but currently I think that's you can deal with this. So just this is one improvement area. Then what I would suggest you, if you use the AWS SDK, please use the newest one. So 0.2 but not the first one. So you have there the lower footprint and it's more modular. And what's really important is that if you need your HTTP client, because you are talking to some, I would say, payment, Stripe API, and so on, so you have to make some HTTP connection, then you may configure your HTTP client. And the situation is we are really we like Apache HTTP client and native and so on, but we don't need them for our Lambda because we don't need caching. We don't need all these opportunities for long-living servers and so on. So previously, AWS recommended to use plain HTTP URL connection client, which will be delivered within Java itself and not this Apache and native stuff. And now, several weeks ago, they released their own asynchronously common runtime HTTP client. And then you see the cold starts when you initialize this client. So there are additional cold starts to load all the things, and just you see that these two HTTP clients have the lowest cold start value. So in case you have to communicate, think of using them, and just it's only the example how you can use the newest HTTP client from AWS itself. So just don't go with native and Apache HTTP client and serverless. The second thing is this is the error that I did when we deployed our first Java serverless application. There are a lot of values which you may not provide, like credential provider, region, and so on. So AWS may figure this out for you, because if you deploy, then just AWS knows what the region is, and they have the chaining for credential provider and so on. But it also costs time, and will cost you more duration if you know that you are in the US West region and you know where you store your credential. So just pass all these objects which you know out of the box. It will save you a lot of time. Just it's about the seconds, the difference if you don't provide those values and let AWS SDK figure it out for you. That's the next thing. Yes, and just the thing which I mentioned, try to do the things which you have to initialize once in this static initializer block. So just if you initialize things in the handler method, it will be initialized each time the function is called. And if you do this in the static initializer block, it's only one time for container, and take advantage of this feature that you will have access to the full CPU core for maximal 10 seconds. So just you can speed up the things there. And just there is another trick which is really dirty for the Java developers. The situation is, it's not enough to initialize, for example, DynamoDB client in the static initializer block. It helps, but in case you are using this client for the first time and you would like to read some item from a DynamoDB, only when you make the get item call or put item call, so you are reading from the database or writing to the database, then during this call, JSON marshallers will be initialized, and it takes probably one and a half seconds for this. And if you are doing this in the handler method, it may take a lot of time. And just if you make a fake call in the static initializer block with some fake ID like 0 or something like this, then you are moving also this initialization step to the static initializer block, which has access to the full CPU. So just sometimes these dirty things which we normally don't do help us to speed up things. So just also you may be aware of those situations of this behavior, just like that the things are taking longer with JSON marshallers and so on. So just you have to know how some client works and to think how I may speed up things, even if it's not the best choice. So of course, less dependencies are more. So we saw that the artifact size matters a lot, and alone with this AWS SDK 2.0, you have the possibility not to include the whole SDK with all libraries. So you just can import this SDK 2.0, and then you can only provide artifacts which you are really using. In this case, we are only relying on DynamoDB client, so we only reference this and no S3, no SQS, and so on. With AWS SDK 1.0, you have just to import everything, and there is a huge collection of services, and you probably don't need them at all. And of course, everybody knows, so just exclude test dependencies, so set the scope to test for everything which you don't need. At runtime, it will of course make your artifact smaller, and of course then speed up things. So this is the first area, and even if you taking care of all these things, you will reduce your cold start just a lot. And of course, just there are other things you have to think of. Just avoid reflection, avoid runtime bytecode generation, avoid runtime generated proxy and dynamic class loading, because the things are really slow and you are paying for the duration. And if the question is, how may I do this? I love Spring. Probably people are are using Juice and they rely on reflection. Probably the Spring relies on all this stuff. And yeah, we will be talking about frameworks like Micronaut, Quarkus, and even Dega. Dega only mentioned there. Just they are not reflection based at doing things differently. So just you won't probably you will be productive with core Spring, but just it's not the best solution for the serverless application because they rely on reflection and may other trade-offs. But there is also a solution there. So strive for the cost optimization. Once again, we have request tier and we have duration tier. And the question is, if I assign more memory, for example, I will assign instead of half of gigabyte, I will assign 1 gigabyte. So also the cost for this memory assignment will double. So double as much memory means double as much cost. But the situation is that with double as much memory, you will get double as much CPU cycle. So you may, your function may run also quickly with more CPU. And just we will be talking about that basic tooling to figure out what are the best options. And the first tooling is Lambda power tuning. This is some kind of state machine. There you can provide your function and then provide different memory settings. And the output will be your best memory and price ratio. So just my experience is that assigning half of the gigabyte or gigabyte of memory provides the best execution duration and price. So just if you pay only a bit more, but you are double as quickly, then it's probably a very good situation. But with this tool, you can figure out what's the best ratio. Of course, it's some kind of static tooling, and just there is just another opportunities to observe your GC logs, just to and then read the information about all these memories, how the memory changes and so on. What memory do you really need in case you are over provisioned, just to figure out can I decrease the memory, and just then probably I will be even as quickly. So this Stefan Grunwald, he works at AWS here in Germany. He provided the solution here, so you can deploy kind of application which absorbs your GC, and then you will figure out what memory is really required. So just because you pay for the memory assigned and not for the memory used. That's very important. If you assign 1 gigabyte, but if your function require only half of the gigabyte, then you are wasting money. So you probably have to revisit and see, okay, will I be double as quick with this, or just it's only waste. So another tooling is just also AWS Power Tools, which provides it's a opinionated tool, but it provides kind of annotations for using the whole observability stuff, like tracing, logging, and metrics, and just simply referencing dependencies. And you can also use a SpecJ Maven plugin, which weaves your annotation at the compile time. And it's very, very important that it's in compile time and not in the runtime, because just all this annotation reflection stuff on the runtime will probably slow you down. So just it's very nice that it works at compile time. And this is a very small example, so how you can configure your logging, tracing, and metrics simply by using annotation. And you can even capture cold start with metrics. So very, very useful tool. And it connects nicely to other AWS services. So logging and tracing with CloudWatch, metrics with X-Ray, just the observability stuff. So just it plays very, very nicely together. So take a look at this. So another question is just, okay, Java 17 will come probably next year, and there are 3 years between long-term version. So just I would like to use some features in between, but AWS doesn't. AWS only supports long-term versions. So just what can I do? It's probably not that I will recommend you to use in your live environment, but there is a tool from frgaal from also German colleague Tony Epple, and what he does, it provides the possibility for example, to use currently GDK 14 features if you're using GDK 11. And what he does is just what he says that just you can do this for every feature which doesn't require bytecode change. And between 9 and 15, there were only modules and records which required bytecode change, and other features like var, text blocks, and instance of, and just everything else. It's just simply you can alter your abstract syntax tree and just do this. So he provides the tool for this, and you can configure this by simply saying that you are using another compiler. In this case, this is frgaal compiler. It's probably only for fun, so just I don't really know if somebody would like to try this out. But just if you see features which make you productive and you don't want to wait until the next long-term support version goes live, so just you can do this. It's probably more for fun. So generally speaking, Java is well optimized for long-running server application with high start times and high memory utilization. So the classic Tomcat web servers and so on. But what you've seen that both memory and execution time are cost dimension than using serverless, and just it doesn't fit very well. And now just GraalVM enters the scene. It's not the talk. We probably have had a lot of talks about GraalVM in general, so we are only interested in some capabilities which will ease our serverless development. But generally speaking, just what is GraalVM? So just you can use the ahead of time compiler, which is relevant. You can mix your programming languages, and just you have the interoperability between all those languages. And you have two editions: Enterprise Edition, Community Edition. Enterprise Edition, you have to pay for this, and you will receive some just a bit more performance. Or you are in the Oracle Cloud, then you probably you will for sure receive Enterprise Edition for free. I think GraalVM 20.3 is released today, so just a lot of improvements in this area. So this is the architecture, which probably it's not very important, but to briefly mention that there is a Java compiler interface above the hotspot, and then you can run Graal compiler on top of this. And on top of the Graal compiler, you have all these GVM languages like Java, Kotlin, Scala, and Groovy. And you have other frameworks to run other programming languages, which is out of scope for today. What is really important is this Substrate VM stuff. And what Substrate VM allows you is to produce the native image. And as you know, native images tend to run very, very quickly. And how they all work, native image works with ahead of time compiler, and the ahead of time compiler does some kind of static analysis, closed world assumption. So just looking for every reachable method, field, and class, and then only just pack everything which you are really using, and then convert this to the native image, like just ALF for Linux, Mac, or for Mac. And there is also just exe also for Windows is currently available. So what this gives us is just Java function compiled into native executable, just with Substrate VM. It will start very, very quickly. So there is also the possibility to pre-initialize static initializer blocks of your function. So just if you are not doing kind of HTTP connection, it's also possible to do all those things. And of course, it requires only very small amount of memory, because just everything is packed together, and everything is pre-compiled. And that's currently what we are looking for. So just all this dimension will save us on cost in the serverless environment. So that's why we will be taking a deeper look on those things. The situation is that you are using managed execution environment, Java 8 and Java 11, and GraalVM is its own execution environment, which is not provided by the most cloud provider, I think. But there is a possibility in the AWS world. You can use custom runtime. So you provide your own runtime, and just it's possible with Lambda layers and Lambda runtime API. So you can even provide Docker runtime if you will. and this allows you to provide your own runtime with this native executable. So what AWS requires is that it's Linux native executable, and if you pack your function, your Lambda function, you should provide function zip, and within this function zip, there should be the file called bootstrap, and it should be your native executable, which you compile with GraalVM. So this way, you may, just with some managing overhead, because you are managing your own runtime, you may provide the native image, which was compiled with GraalVM native image possibility. So this is kind of door opener to use this GraalVM with the cloud providers. I know that Azure and Google have their similar capabilities in this. Generally speaking, GraalVM are not forcing you to use ahead of time compiler, so you may decide to use even just-in-time compiler. It's up to you. And of course, everything has a trade-offs. And in case of just-in-time compiler, it's optimized for the peak throughput and reduce maximum latency just for long-living application. And ahead of time compiler is optimized for startup speed, low memory footprint, and small packaging. And these are the characteristics of the serverless application. So just you want this red thing. And of course, native image compilation takes time. So just something between 2 and 3 minutes for very simple function is normal thing. So just it feels a bit different just comparing to just-in-time compiler where you require several seconds to compile your simple function. So just another trade-off. But of course, we would like to be productive with the frameworks we use. So just we love Spring and so on. Just we don't want to give up this possibility. And then we will be very briefly talking about these 3 frameworks, how they adopt GraalVM, just starting with the Micronaut and Quarkus, which were built with serverless and even microservices application in mind, and what the Spring does to adopt GraalVM. So the common principles for all these frameworks, they rely on as little reflection as possible. So just also Spring GraalVM project, not the core Spring. Of course, they avoid runtime bytecode generation, runtime proxies, and so on. So all this stuff adds, it also takes time, and it also caches a lot of things which requires memory and so on. So just it's not the way to go on the serverless application. So they avoid using them by design. They process annotation at compile time, just for the reasons stated above. And they have the goals to increase developer productivities for sure, and of course speed up start times and decrease memory usage for microservice and serverless Java applications. So they are not just only for the serverless environment, but also for the microservices as well, and not for the long-lived server applications. And just they can deal with both GraalVM native image, or you can use these frameworks even plain, just without providing GraalVM, and you will also be productive and save on call start time. So just very, very briefly, because probably you can have the separate talk for each of these frameworks. So starting with the Micronaut, it's developed by Graham Roche and the team. So probably you know them, and you know him for his work on Groovy and Grails. And Micronaut is supported by Oracle and Google, and Graham Roche joined Oracle several months ago. So probably we will see tight collaboration, and how you write your Lambda function. Just here, the example, you implement function interface from Java 8. Business logic doesn't matter, and you nearly don't see any Micronaut logic. The only thing that we declare function bean with some name, and in using this import from function bean. What I really like for Micronaut, it provides the validators out of the box. You have also API gateway integration, so just for public facing application. And what it allows you is to use your Spring annotation. So if you are very, very familiar with Spring and want to use this annotation, it's not the problem. Then you can define annotation processor, so the Micronaut can convert this Spring annotation into Micronaut annotation behind the scenes. So just if you are familiar with all the Spring stuff, so you can use this, and that's probably the only one dependency to the AWS function, and it also only in the dependencies. So the thing is that currently there is a Gradle plugin. I'm more than the Maven user for building GraalVM native image with a plugin, or just, yeah, it's not very convenient, but you can do this yourself. If you have your jar package, then you can build your native image with GraalVM and then pack this into this function zip and rename the native image to Bootstrap. So I'm currently waiting for the Maven plugin. It should be released probably even this month. Quarkus, the same goals, but it's supported by IBM and the Red Hat, and the programming model is similar. So Quarkus and Micronaut are very similar frameworks with the similar goals. And what you see that in this example, we implement request handler from Amazon package, and just there is no dependencies to Quarkus in this example. But what I really like for Quarkus is that they provide Maven plugin to build this native image, and just you see how to do this: profile native, and then simple also provide your plugin and then execute native image goal, and simply with Maven -profile native reference into this, you can build your native image out of the box. So this is really easy. Just what I love in Quarkus, they provide the website like Spring initializer for creating the app. For Micronaut, it's only possible with scaffolding, so just command line. They also provide integration with API gateway for public-facing applications, and also they provide support for Funct. I won't go deeper into this, but this is kind of generic way of writing serverless function, which will be deployed across different cloud providers. So if multi-cloud is some kind of the option for you, then take a look at this. I'm not a stronger believer for multi-cloud things, but probably there are companies which have to think about adopting different cloud providers. So that's kind of that you will have portable applications, but there will be really limited. So now we will go to the Spring Boot framework, and the situation was, of course, not very good, because Spring is designed with all this reflection stuff for all long-lived application, and the people struggle. So just it's not an option to using Spring, classic Spring in the serverless world, because of just all this stuff that will cost you money. And of course, also Spring users and then also VMware company had to think about adopting serverless and microservices in their application. And 1 year ago, they started Spring GraalVM native project. So just they started nearly 1 year later after Quarkus and Micronaut, and just we see that they are way behind this by all statistics. But the goal is just to provide Spring developers this GraalVM native capabilities, and just it works similar as an example. So just this the same thing, we implement function interface. I think just we use some Spring annotation, but generally speaking, it works in similar. The situation is that you are currently required to use application class with Spring. You require this Spring Boot application annotation and proxy bin method false, because default the CGLib proxy will be used in the Spring application. GraalVM only requires GDK proxy. So with this, you switch to the GDK proxy, and then you have to register all your bins. And this is the bin which we implemented here. Just here with register bin, it's not very convenient. Probably it will disappear sometimes later, but just currently you have to do this. And the Spring also provide the Maven plugin even more flexible as Quarkus, because you can also provide here build arguments, additional build arguments for GraalVM native image and so on. So just the situation is, if we will compare all these frameworks, I won't compare this because these are not only serverless frameworks, but also for microservices. Just probably the situation depends on the release, which may occur each day. So it's up to you to see what's the best thing. But for serverless applications, so just these are the parameters which we like to compare. And my feeling currently is that the Spring will have probably the hugest cold start and memory consumption and so on. So, and Quarkus and Micronaut are really comparable. So just it's a matter of taste, and so figure out for yourself. With the native image, you have the build time, but it's not related, not strongly related to your framework. It's related how GraalVM native image works. So probably conclusion. So just GraalVM on all these frameworks are really powerful with a lot of potential, and just even simply use Micronaut and Quarkus, it will improve your cold start with Java applications significantly, even without GraalVM in a native image, and it will make you productive. Just because of the things we'll talk about, as little reflection as possible, and they really reduce cold start duration. But in combination with GraalVM and native image, there are a lot of challenges. So just AWS custom runtimes requires Linux executable only. So just for Mac and Windows people, they have to use Docker. And also managing custom runtime requires additional effort. So just it's not AWS managing your Java runtime. Now you are responsible for this runtime. And it also has some kind of performance impact if you provide this custom runtime instead of using the managed one, because there are additional API calls. In between, the penalty is really small, but there is one. And in case you are building a native image and you are not experienced a lot and you are using some dependencies, you will first time experience a lot of errors, and just there is a link with the Stack Overflow how to deal with this. It's very unusual. So you are doing simple things and then just you see a lot of GraalVM exceptions. So you have to experiment a lot of these additional build arguments like initialize at runtime, delay class initialization, and so on. It sounds a bit weird for the first time because it's very simple function. Why do I need this? But yeah, generally speaking, so I would say it's probably too early to go with GraalVM. It's my opinion. So just it has to become more mature so that the people use this native image. But this probably is the way to go. So I hope that in 1 or 2 years, even the build time will be much quicker, and just all this exception will disappear, or will be a lot of best practices how to deal with them, so you can become productive very, very quickly. So if you want to try out this yourself, so I have posted the links for some basic application, like for all these 3 frameworks, and this is the LWS repository. There they provide the sample application with all 3 frameworks and update this very often, so you can just check it out and try it yourself. Probably the last thing to mention is just so-called Project Leiden, which was initiated, or the discussion was initiated by Mark Reinhold from Oracle. And what they would like to achieve is to provide the native image functionality in the Java itself. So not with the GraalVM, but with the OpenJDK itself. It's not clear what the separation will be between GraalVM and these capabilities in Java, because just Oracle wants to earn money with GraalVM. And will it replace GraalVM or not? But just it's only the start of the discussion, so it will probably take years before it's implemented. As far as I understood, this project should provide the common APIs for dealing with the native image capabilities, and just GraalVM should use this API. So just there will be some intersection, but probably also there will be some kind of separation. So my hope is that this native image capabilities will be provided by the Java runtime itself, so we don't need to provide this managed runtime. So this will be a lot of easier, that we will get rid of these custom runtimes and so on. So that's probably something for the future. So that's probably all I wanted to talk about you. So I hope that wasn't very boring, because just a lot of technical stuff. So I will send this presentation so you can take a look at some specific improvements and just read all the links which I've gathered. So I'm will be really happy to answer your questions. If you have them later, so you can contact me even via my private email. So I will be happy to engage with you.
Yeah,
thank you very much.
Yeah, thank you, Vadym, for the presentation, and thanks, guys, for attending our virtual meetup. So let's jump quickly to the Q&A session. So we have a few questions for you, Vadym, if you want to take them, or we can take it one by one.
Yeah, we can take it by one. So
okay, so the first question comes from Daily Waterworth, if I pronounce it correctly. Hi, wondering what the project structure would look like, say if I had 10 lamps, how would this build and be deployed? So it's the first question, Vadym.
So the Lambda, so you have to package on Lambda separated. So probably so you will have to just one Lambda is one package with the code. So the question is, of course, if I have some shared code between this Lambda function, how I can use this. And there is so-called also Lambda layers, so you can reference some shared code by this. But of course, each Lambda should be deployed separately. So they just probably there is a monorepo discussion. Would you like to have builds, so just Git repo for each function, or you would like what's the structure? It's probably opinionated. You can go with each approach, but if you deploy the function, you deploy only. So it should be only one function which implements this request handler method, and other functions just they are completely separate.
Okay. So the second question comes from Neil Brown. So what deployment tools, frameworks have you used? Do you recommend for serverless apps?
So I just skipped this part because of the complexity. So I use SAM, Serverless Application Model, for this, and just this totally fine. You can use serverless framework if you would like, but just with these two you can go. So the serverless application model is from AWS itself. So just it provides the easier way to package your application and to deploy your application, and just that's probably a good way to go. We probably skipped one question from James Hex. I see. Yeah, he used Spring Cloud function.
Sorry, James. Yeah, sorry, James. So on the Spring front, I have used the Spring Cloud function approach, and had around 1.5 second called startup. Does that approach use Graal, or could using Graal further improve?
So in case if you're using GraalVM native image, your cold start time will be something like 100 milliseconds. So just native memory, native images start very, very quickly. So just it's way better as JavaScript cold starts now. So just the cold start problem itself disappears. Of course, if you are doing heavy work in your static initializer block, then of course, but if you are not doing wild things, it's just, yeah, it's not an issue anymore. So just that's so quickly, and just it uses so low memory configuration that all this. So you're probably good to go if you sometime become productive with all this GraalVM native image and it will become mature. Then that's probably no brainer more. This all cold starts, just forget about them. That's my opinion.
Okay. So next is come from Alexei. I don't know if a comment or a question. Can you read it for us?
Yeah, so Alexei has announced that he will ask questions on LinkedIn, so just I'm not surprised. Hello, Alexei. So yeah, it seems there is a lot of not straightforward workarounds in the way to native Spring Lambda with GraalVM fast. That was supposed to be the way of doing less operation, attention, productivity. That's a very, very valid question. So the situation is that as we started adopting serverless 2 years ago, so many Java developers converted into the kind of JavaScript, TypeScript developers, just or Node.js developers. That's what's happened with our company. And of course, it's for the first time, it's loss of productivity because just people have to learn other programming languages and become productive with all this stuff because there were no GraalVM and something like this 2 years ago, and there were no runtime custom runtime options. So just you had to use plain Java, and there were no Micronaut and so on. So just plain Java would use this for very simple projects where some heavy calculation will be done only one time on the first of the month. Then cold starts were not very important because it was a synchronous application, and also the costs were just we paid $2 more per month. It's just not worth mentioning. So for some kind of application, even just normal Java was okay. But of course, if you have some kind of public facing request, so just you have a lot of million requests, and just it's about money, and it's about also latency, then of course Java just kind of struggling, but searching the way out of this. So just probably I would recommend you put GraalVM outside and simply use plain Java managed runtime with Micronaut or Quarkus. Just you will reduce this cold start. You will be productive with all these frameworks because they are very similar to Spring Boot, just with the programming model and so on. Yes, you will probably experience some cold starts, but it depends on your use cases. If you can do things asynchronously, then it's not the issue. And if you pay more for your cloud bill, but you are productive with your Java developers, then productivity is also money. So just start with this, but probably the hottest function, probably rethink. You can, with what I like with serverless, you can re-implement some functions with other programming languages if it's the issue for you. So small functions just can be re-implemented very quickly. That what I probably suggest you. That's the way how I do this. Alexei, have I answered your question?
I just want to mention, guys, you can unmute yourself and you can ask or ask directly, right?
Mm-hmm.
Okay, so we have another question from James. So James said, with the required change to make things serverless ready, do you feel we lose too much of the Java loveliness? So much so that it could be square peg round hole at the moment.
So as I've mentioned by answering the last question, just using Micronaut, you just have the same annotation, but they will be processed differently just because just a lot of compile time work is done, but it's also dependency injection. It's just that's the same programming model, but they just make other trade-offs and just they increase a bit compile time and so on, but just it's a matter of several seconds there. So just I don't think that I lose productivity with the Micronaut. So just it's very familiar model, and just they have the advantage that they started as they saw that Java struggled with serverless, and the Quarkus just the same thing. So just they made other trade-offs designing the application. So just for me, I feel pretty comfortable, and Micronaut is currently for private things which I'm testing is the way to go from my side. But this may be opinionated. So just as I mentioned, try and put GraalVM native image and GraalVM itself by side. So observe what's happening there, and try playing Java execution environment and Micronaut or Quarkus.
Yeah.
Okay, I see.
So,
very many.
Vadym,
Thank you.
Yeah. They're asking for the slides. So it will be with the video, or you're gonna share that, right?
Yeah, of course. I can send them to Barry or to Dominic, simple share this on Meetup page. So just put in comment below. So I have slide share, so I will put them today or tomorrow, so just you can have access to them.
Yeah, we have maybe a last question from Michael. Can you take it, Vadym, please?
From Michael. So I see a lot of.
Where is it?
So I see the Evuhed, who had experienced 30-second startup time. So that was what I have experienced with my first function. I was also shocked, but just because the function was executed only one time per month, it just didn't matter for me. So I think, so yeah, he loves to see the slide. Okay, Alexei, okay, it's only the comment. So James, thank you for answering. So, okay, Michael, yes, I see. If I'm equally familiar with Node.js as I am with Java, would you pick Java for serverless? I would pick Node.js for serverless currently, because just if you are familiar, just then it's totally fine. So just as I mentioned, we've converted Java developers to Node.js developers because just there is a lot more tooling around this, and of course we have some applications which are public facing, which are really build sensitive, I would say. So just that's okay. Yeah, but observe Java space. So just there will be things for sure. But I would prefer Node.js or TypeScript or something like this. The same will be true for Python. So if you have Python developers, so do things with Python. It's not a problem. It's probably not what I should say in the Java user group, but but that's okay. If you are productive with both and just you see the issues, and just somebody mentioned ugly workarounds, and I can agree these are ugly workarounds. So normally you are ashamed doing the things. Just and it doesn't feel very natural currently.
Okay, so I think that's all the questions from guys. Any other question? Alexei? Oh, okay. He's just commenting. Okay. With that being said, Vadym, thank you so much for the presentation, and thank you so much, guys, for attending. And see you next time, hopefully.
Yeah, thank you for the invite.
Okay, so see you later, guys.